Since the dawn of humanity, we've gazed up at the stars and dreamt of exploring the cosmos. But reaching those distant worlds requires immense power. Two technologies have come to symbolize this quest for the stars and, unfortunately, our capacity for destruction: rockets and nuclear weapons. Rockets, with their fiery plumes and thunderous roars, represent our ambition to break free from Earth's gravity. They carry our satellites, telescopes, and astronauts into the vast expanse of space, expanding our knowledge and pushing the boundaries of human ingenuity. On the other hand, nuclear weapons, with their unimaginable destructive force, represent a darker side of human nature. They remind us of the immense power we wield, and the potential for self-destruction that comes with it. Understanding the difference between these two technologies, their underlying principles, and their intended purposes is crucial, not just for scientists and engineers but for all citizens of the planet. Rockets work by harnessing the power of chemical reactions. Imagine a controlled explosion carefully directed to propel a spacecraft upward. At the heart of this controlled explosion lies rocket fuel. Different types of fuel offer different advantages. Solid rocket fuels, like those used in some fireworks, are relatively stable and easy to store. They consist of a mix of fuel and oxidizer, a chemical that helps the fuel burn. Liquid rocket fuels, like liquid hydrogen and liquid oxygen, offer more control and efficiency. These fuels are stored separately and mixed at the moment of ignition, creating a powerful thrust. Hybrid rocket fuels combine elements of both solid and liquid fuels. They offer a balance between stability and control, making them an area of active research for future space missions. Nuclear weapons, unlike rockets, don't rely on chemical reactions. Instead, they tap into the immense energy stored within the nucleus of an atom. This energy is released through a process called nuclear fission or nuclear fusion. In nuclear fission, the nucleus of a heavy atom, like uranium or plutonium, is split apart, releasing a tremendous amount of energy. This is the type of reaction that powered the first atomic bombs. Nuclear fusion, on the other hand, involves fusing together the nuclei of light atoms, like hydrogen isotopes, to form heavier elements. This process releases even more energy than fission, and is the same reaction that powers the sun. Section 4, Rockets and Nukes, Different Purposes, Different Effects. The most crucial difference between rockets and nuclear weapons lies in their intended purposes and effects. Rockets are tools of exploration, designed to carry payloads into space, expanding our understanding of the universe and enabling communication and navigation technologies. Nuclear weapons, on the other hand, are weapons of mass destruction. Their effects are devastating and long-lasting, causing widespread damage, radiation sickness, and environmental contamination. While rockets have played a vital role in advancing our understanding of the universe, nuclear weapons represent a grave threat to humanity and the planet we call home. Section 5, Why It Matters. A Universe of Differences. Understanding the difference between rocket fuels and nuclear weapons is not just an academic exercise. It's about recognizing the power of science and technology, both for good and for ill. Rockets represent our drive to explore, discover, and connect with the universe beyond our planet. Nuclear weapons, on the other hand, serve as a stark reminder of the destructive capacity of our own inventions. As we continue to push the boundaries of science and technology, it's crucial that we do so responsibly, ethically, and with an eye towards creating a future where the wonders of space exploration are celebrated and the horrors of nuclear war are relegated to the history books.